All right, on to the next one. This one's RBD, talking about async mirroring. Josh, you want to give an overview of this one?
So the general idea is that right now you can replicate RBD images synchronously within a Ceph cluster, but it's the kind of options you have for disaster recovery, for synchronous, for like making backups or copies in a different Ceph cluster, possibly in a different data center or geographical location, are kind of okay for slow or daily backups, or perhaps on a larger time scale. But it'd be really nice to be able to have something that's a point in time consistent with whatever point in time a separate site happens to be at, and can be kept closer to the current state of things. And so that's kind of the high level goal, to be able to have disaster recovery when one data center goes down. Your RBD images are still in a consistent state, in a separate data center. And the means that we're talking about to accomplish that are an asynchronous replication mechanism built on top of a full log of all the changes that are happening to an RBD image, which is all the data, all the writes that are happened to it, and all the metadata changes like creating snapshots, resizing it, flattening it, that kind of thing. So at a high level, I think it would be nice to have the user interface be able to kind of enable this kind of replication on an entire pool. So you could be sure that your whole pool of OpenStack volumes is being mirrored to a different data center, but as well as making it more flexible for the future. So being able to enable and disable it on a per image basis too. So there's some details in the Etherpad about some thoughts about how this could work. This is kind of all is just a basic draft of the design right now. So none of this has been implemented yet at all. So it's all still very subject to change. So the general idea for the journaling the changes is that now that we have exclusive locking for RBD images, you can have the single writer to the journal and make sure that there's only one client updating it at a time. And so that single client who's opened the RBD image for writes and is doing writes will also be updating the journal with any writes that they do, and they'll be updating the journal before writing back to the backing RBD image. And this journal would basically be striped over objects in possibly the same pool or possibly a different pool. It could be like a pool of SSDs to speed up writes, for example. And this could be operating in write back mode, where you don't actually write, you consider the write complete from the cache's RBD cache perspective or the guest perspective if the cache is disabled once the write is in the journal, or in write through mode, where you consider the write complete when it's written to both the journal and to the actual RBD image that's currently in use. So the idea for kind of implementing this would be to reuse or create a new version of the kind of journaling mechanism that exists for CephFS and make it more generic. It might be a good idea to enable it to stripe with kind of fancy striping parameters so that you could get more parallelism for many smaller IOs to the journal. It might be a good idea to also allow the objects to be slightly variable in size with like kind of like a minimum size to fill up an object before moving on to the next one, just so that there aren't kind of any strange alignment or boundary constraints. In general, for the journal, you'd want to have, since you're doing write back at some level, even if you're in write through mode, you need to keep track of like which writes have actually been flushed to the image, so you can know whether you need to replay them. So there needs to be some metadata associated with the journal as well. And I was thinking this might be best stored in some kind of journal header that would record like all the information about the journal, like the striping policy for the journal, the specific prefix used for the journal, kind of similar to an RBD image header, but also recording different kinds of positions within the journal. So one would be just the flush position, which is how far back we are from where the RBD image is, or from where the file system is, and how much still needs to be flushed out from that journal. If we crash and the client restarts somewhere else, it can start from that position and replay the journal from there. And for the actual mirroring, it would also need to have some positions on a kind of per site basis or per zone basis. I've kind of been referring to the extra site size zones in this document, but I'm not really stuck on that name. We could just call maybe sites to be clear. There's no kind of concept of this kind of configuration level yet in RBD or Ceph generically. So we need to have some kind of position markers for how far along different sites are in replicating this log, and from based on those positions, we can tell how when we can actually trim the journal. So that's kind of the basic design I have written down for the journal right now. Does that kind of make sense to people?
So Josh, one question. So is this a complete data journal, or you are planning to write only the metadata on the journal?
This would be a complete data journal, so that you would be able to have a consistent point in time view of the image as you're replicating it. So it would include both data and metadata.
Yeah, so basically it will be similar to the Ceph OSD journal that actually we are using on the OSD site, right? Everything will be reading there and then replicating. So so then one concern I have is that, say, if somebody is writing from image from a LUN, so data will be actually written there as a journal, extra data, and as well as if somebody is using file store, they will be also writing twice. So basically it will be replicating data on both the ends. So more writes everywhere.
Yeah, there's definitely some write amplification.
Especially if you stick with the current.
Yeah, especially the current file store. One thing that helps with that is like the RBD cache in general. Since we'll be hopefully be able to use this in writeback, the cache in writeback mode, that'll queue up more writes and write that out to the journal. And if we're using the journal in writeback mode, we can also delay writing out actual changes to the image for a while and make those asynchronous to the guest, so it doesn't necessarily affect the guest performance unless there's a really sustained period of heavy writes.
This is the same trick that Cephfs does, where it has a really big journal and everything in the journal is durable, and so it lets it sit there for a long time. So when it finally does go update the actual object, you have all of the writes on that object over a long period of time get coalesced into like one big IO. So it will amplify, but the more, like if you have lots of 4K IOs, when you eventually go and actually do them on the actual object, you'll do them all at once. And when you do them in the journal, they're sequential, and so it's hopefully cheaper. So I think that the bigger the journal gets, or the bigger the write-back cache is effectively on the RBD client, then the better that will work. I mean, if you're doing random 4K IOs across the entire image and you never touch the same object twice, then obviously that doesn't help. But I think in most workloads, that's not true. You usually have quite a bit of locality on the block device. The other thing is that we want to replace the file store, which we'll talk about tomorrow, I think. And in the new store implementation, appends have no double write. You'll just append to an existing file, and if we have to roll back, then we truncate or even just ignore the end. But there won't be a double write in the append case, so that will help as well. That's a little ways down the line.
Someone in the Blue Jeans chat is asking, Amazon allows us to take a snapshot of a volume to object storage for accessing another zone. Since we already have object replication across zones, could we provide facility to take a snapshot to an RGW object? Well, we could do something like that. We kind of already have that in the form of RBD differential snapshots that you can use to do offline backups when you take snapshots manually and replicate them. But that doesn't really scale very well for doing that across like many hundreds of images or thousands of images in a pool, and doing that on a continuous basis. So the mirroring will really give you make it much easier to use in terms of being able to like, configure it on a per pool basis, for example, and providing more orchestration around actually using it during the replication, and also being able to have a backup that's closer in time to what the current state of things is if the first site fails.
And more efficient.
So yeah, and more efficient because it can do more coalescing of writes and that kind of thing.
So could we only mirror a image in a pool? Only mirror one image?
Are you asking if it could be done on only one image instead of a whole pool?
Yeah.
Yeah. So that that's definitely something we want to allow. I think my thought is that it would basically be a feature bit to enable the journaling, and so you could enable that or disable that on a per image basis. And it could also just be a basically helper command that would be enabling it on whole pool, which would essentially be a for loop over all the images, in addition to setting some like date in the pool, so that new images get that feature enabled by default.
Yeah, from part I see we need to journaling the whole pool data, and then if we only want to mirror one image, and can we disable other images journaling?
Yeah, so you'd also be able to disable it too, I guess. So the way that you do that would be, at least with this design, how it would work would be, if it's enabled on a per pool basis generically, the image would have that feature bit by default, but as soon as you create it, you could immediately then disable it. Or conversely, you could not enable it on the pool in the first place and only enable it explicitly on images that you want to be replicated or mirrored.
Yeah.
So, Josh, maybe a dumb question. So, since it is asynchronous, right? So, why we need to maintain the entire data on the journal? So, can't we have some metadata pointing to the objects that will contain on those images and all, and then some agent that will actually read the object and write it on the other end?
Sorry, I think I missed the last part of that. Can you repeat that?
Yeah, so what I'm saying that since it will be asynchronous, right? So the image will be there on the say primary server and all, right? So and can't there be some kind of metadata or some pointers, right? Like say the marker that the other end actually will connect there and then run through this metadata and get the actual object from the metadata and run and copy the data other end.
You're talking about.
I think what he's saying is have the journal basically to say, hey, we've already written the data. It's final location in this object at this offset, this byte range. But then the problem is that you don't get consistent. You wouldn't get consistent replication over potentially if you're not journaling the data.
You could maybe do a metadata entry in the journal that says I'm about to write this extent, and then go and write the extent. But then you have to deal with like the race case where you wrote to the journal but not to the device, and so you'd have to like have a sequence number in the journal and tag the RBD object with that same sequence number, so you know that you're at the position. that you've caught up that far, and so that gets a little bit weird.
Yeah, I am
the
trying
other thing
to
though,
copy and somebody. I am trying to copy and somebody deletes the object, something like that.
Yeah, or just the writer failed. Like they said, I'm about to write all this stuff, and they failed before they actually wrote it. And then you're like, at what point do I throw out that? I guess when the locker takes over. So maybe you could make some recovery path. But I think that the bigger issue with that is that assuming you did that, if you have a somebody who's replicating the journal, actually doing the mirror, that means that they have to follow the journal and do all these random IOs to all these other objects all over the place. So I guess everything will be warm in the cache, so it might work. might not be so bad, but it's a little bit more complicated. I don't know. I have to think about it. I guess that's feasible, though. Maybe we should talk about that one. Think about that option. Does that make sense, Josh?
Just generally, trying to like tag rights with the version number that is in the journal, so you can tell which objects have been overwritten later, or
or you can tell that. So assuming you're watching the journal and it says I'm about to write this extent, and you go to that object to try to read that extent, you want to make sure it actually wrote before you read it and go replicate it. So you would pull the object until you see that journal sequence number has been sort of applied to that.
But if your replicator is behind and it's already done 5 more updates to that object by the time you get to actually read that block.
Yeah, then you lose it. Right.
But then
that's the reason.
There are updates in between that went to totally different OSDs that were blocked or delayed or whatever. You can't get back to the consistency of the replication. That's true.
Yeah, that's it. Yeah, okay. What Jason said. That's why.
Right.
Yeah. Yeah, I mean, having a full data journal is expensive if you do it naively without sort of optimizing around it, but it enables like a whole class of other really cool stuff. Like you can do delayed apply, so you could have your replica be exactly an hour behind. You can fast forward. You could even make a rewind if you make a reverse journal. I mean, there's all kinds of cute stuff you can do. Assuming you can pay the performance penalty, and if we do stuff like this write back, like making a large write back window essentially and coalesce writes to objects, then we can mitigate a lot of that. Or you can put the journal in a flash layer in a flash tier.
Put the journals in a nice fast pool that is much smaller, but just sized for the journals themselves.
Right.
Yeah. So that was my next question. So can we put this journal to a different pool, like say it's not SSD or something, and then we can actually deal with that? Yeah.
Yeah, we can. I think that's definitely one of the goals. There's no reason why we couldn't.
Mm-hmm.
There are a few more questions in Blue Jeans chat, at least. So someone's asking if this would be consistent per image, and I think that's true for now. Potentially in the future, we might be able to have images like share the same journal if they were in some kind of consistency group. But for now, just one per image. Also asking about how we handle resynchronization. So for kind of a failover scenario, basically what you'd want to do is when you fail over to the secondary site, you'd want to have this journaling enabled there as well, so that you could keep track of more any changes that are made there since the failover, and kind of if the first site comes back up, you would probably want to store the flash point in both the first site and the second site, so that the journal position in the first site and the second site in terms of where the second site had replicated to on each image, so that you could tell how far back you have to roll back in the primary zone. And since you're doing this full data journaling in the original first site, you can just easily go through the operations that happened between that weren't replicated, mirrored to the second site, and roll all those back, and then catch up with any other changes that have been made in the second site since then, based on the second site's new journal.
Yeah, I think there might be two cases. Like the data journal will tell you which things have effectively were divergent, like that didn't get replicated. So that's the stuff that you need to roll back. And it might be that the same extents haven't been touched at the target, so you can just copy them and you can actually roll them back sort of explicitly. And if that fails for some reason, like they've been overwritten and you don't want to like roll forward and get into an inconsistent state, you could actually roll all the way back to I guess we're already inconsistent, so it doesn't matter. So you might as well just copy it. Yeah. But you could also roll back to a snapshot and then replay the journal from there if you wanted to.
Yeah, you could potentially roll back to a shared snapshot and replay from there instead.
Yeah. But yeah, a couple different options, I suppose.
Someone's also asking about the speed of snapshot and copying objects to a different zone or versus async replication. So there's a kind of two different or several different costs there. One is that snapshots do incur like the copying write overhead, so they make more writes, new writes to reach the snapshotted objects slower, since they have to do the whole copy and XFS. In terms of the actual like amount of data transferred, I think it's pretty similar. Although we can do some optimizations with the asynchronous replication by having, for example, having the replicator things during the replication have a large buffer they read through the journal, and so they can not replay every single write if it's overwriting the same segment more than once. Only write the last one in their buffer. So there's potentially some other kinds of optimizations we can do there, perhaps. So I think in general, the async application will be able to be faster because of that.
So, sorry, random thought, going back just a second to the question of whether we want to do, whether you'd want to put the journal in a different pool that's faster. It could be that even if you don't do that, we just hint the journal such that if there's a cache tier configured for the base RBD pool, that it just ends up always living in the cache tier. And the writes to the blocks are hinted such that they tend to not be promoted into the cache tier or something. Like you could probably end up with the same thing with that, actually, just by leveraging hints.
Yeah, we could potentially
maybe
do that
kind of
without having
delicate,
to configure a separate pool. I mean, for many setups, it wouldn't make sense to use a cache tier for the random IO that you're having to the RBD images in general. So maybe that setup is kind of more specialized, but
yeah. I think Josh's dog agrees.
Riling my dogs up.
Sorry, I'm gonna go quiet them 1 second. I'll be right back.
All right. Okay. Well, there might be. Are there other questions on this one? We might be done.
If we don't take a break, we'll be ready to start the next session.
Oh my gosh.
All right. Well, we didn't really talk about the how the replication agent actually works at all, but we can kind of discuss that some other point if you want.
It might make sense just to talk really quick about what use cases we want to cover, like whether it's per image, per pool, whatever. Because I think ideally the sort of the low level nuts and bolts of it would be on a per image basis. So you could always do it at that granularity, but you'd want to make it easy for a user to say, I want this entire pool to be set up over there, and have some other thing orchestrate all that replication, I guess.
So
yes, my thought would be
the journal will be per image, or it will be common for all the images?
The journal would be per image, so that you could enable it and disable it for a given image. And you could have different, you could have easily parallelize the replication that way too. So you could have different replication agents, like logging different images to do the replication on their log in the secondary site.
Mm-hmm. Mm-hmm. Unless you wanted to have a consistency group where a bunch of people are sharing a journal, maybe.
Right.
But it might be, yeah. Yeah, then you have to worry about concurrency and like when you move to the next block of the journal and whether it's possible to stripe while having multiple writers and all that stuff. It gets a little bit trickier.
Yeah, exactly. Having one writer to the journal is one of the easiest ways to make it work efficiently.
Okay.
And yeah, I think laying consistency groups on top of this wouldn't be that big a deal. Just having multiple images logically share a journal and being essentially one logical RBD image, assuming that they're not used from multiple places at once. And if they are used from multiple places at once, then we have to rethink this a bit to make it work better for them.
Yeah.
So that's maybe a question we should look into
Is the one of the starting point for this is sort of building the journaler, the Rados journaler module code?
Yeah, I think that's probably one of the first steps. Building a generic journaler module that will be useful by this and FFS or anything else that wants to journal on top of Rados as well.
Yeah.
And for the per image versus per pool thing, I think it's pretty simple to make it like a feature bit that you enable or disable for an image, and you can do that dynamically, perhaps. Although the dynamic part gets a little complicated if you have existing data. And then just having some wrapper commands that would be able to enable everything on a pool-wide basis.
Yep. All right. Let's see. Lars says snapshot a pool and replicate the whole delta. I think Lars, we do. There's sort of a separate effort to do that at the Rados level, where you take the entire pool and you create a Rados pool snapshot. Although I don't know if that won't work with Rados images or block device images because they love. Yeah, right now pool snapshots don't mix with self-managed snapshots.
Maybe we could fix that.
Yeah, it could. It's a small matter of writing some code. Yeah, but he says consistency groups are quite important. Yeah, I think so. I mean, we have to sort of solve this generic consistent snapshot issue anyway, where you have a bunch of images and you want to snapshot them together. And so it might be sort of the same thing in the whether or not they're journaled, where you sort of pause them, tell them all to snapshot, and then let them resume or something like that, in order to get that point in time snapshot.
Yeah, and I guess for the journal, it could just be end up being appends and not worrying too much about having different size objects, since it's nicer to have variable size objects anyway.
Yeah, you can just make sure you don't, just append until objects are roughly this big and then go on to the next one. Yeah. Sounds good. Okay.
So that actually wouldn't be too bad. I guess we've probably exhausted our time pretty well already, but any other questions?
All right. Sounds like we're good on that one.